I'm Phil, and I'm here to give you the verse update together with Tim Tillotson. So let's get started. So the agenda is first I'm going to review the verse programming language and some of the things in case you don't know what it is already. Then I'm going to go into new language features that we've shipped in the last year. And then I'm going to go into some of the details about our language versioning policy, a new feature that we've added called Runtime error telemetry, another new feature called incremental garbage collection. Then I'll give you an update about transactional memory in verse, our reference implementation, the new virtual machine for verse that we're working on, and then I'll hand it off to Tim for the verse framework update. So what is verse? Verse is a new programming language that's intended to be just code. So all of the things in your game and all the things that you would want to do in your game, like accessing a database, communicating over a network, all of these things are expressible as language constructs. So rather than having to have a mix of JavaScript, SQL, CSS, whatever, in verse, you just write code. You just write code in verse. Verse is a transactional language. This is our plan for how to enable concurrency, parallelism in verse, and also to support things like accessing databases and doing networking. In verse, your code is always running in a transaction, which means that you can abort the transaction and it's as if nothing ever happened. And that'll also allow us in the future to allow code that you wrote that is seemingly sequential code to be run in parallel. And verse is just one language for everything from the code to the data to markup. What that means, for example, is if you have an asset in your game, then that asset shows up in verse as if it had just been a verse class that's being instantiated. What we shipped a year ago is a subset of the language that we're calling beta verse. And what we're working towards is the maximal version of the language, which we're working on specifying, and that's what we call max verse. So between a year ago and the future, we're going to be incrementally adding features to the language so that they're backwards compatible to beta verse and forwards compatible to max verse. And I'll tell you a little bit more about max verse and our plans there later in the slides. So now let me go into some of the new language features we shipped in the last year. A super exciting feature is the editable attribute, which allows you to mark up properties in your code more easily for the editor to be able to edit them. A major feature that we added is persistence, and I'll tell you more about how persistence works. Then I'll go into backwards compatibility checking, which is closely related to the persistence feature. And then I'll tell you about new attributes that we've added, experimental and deprecated, that enable better language versioning and better API versioning. Later in the talk, Tim is going to tell you more about asset manifests, which goes back to that thing I was saying earlier about how assets in your game show up as just code. Tim will tell you more about that. Additionally, in the last year, we've refined qualifiers and effects in verse, but I won't go into the details there. You can find more on that online. So I'll be going into the details of these first 5 things. So editable. This is really cool. Say that you have a property in a class called time between attacks to float, and you want to be able to edit it in the editor. You can add the editable slider attribute onto it. That's one of the family of editable attributes you can add. And here, what you can see we've done is we've given it a category. The category dictates where in the editor it'll show up. So the editor will organize your editable properties into categories. And you can even give it a tooltip. So in this case, the tooltip will say the amount of time between each attack. And the category will be tower attack. And then we've constrained the property so that in the editor, you'll only be able to set it to a minimal value of 0.5 and a maximum value of 10 with a default value of 3. And there's a family of additional editable attributes for different types. Slider is just one of them. So now let me talk about persistence. Persistence in verse is closely related to how global variables work in verse. Verse is novel in that in verse, a global variable is truly global. So if you write a global variable at the top level of a module, that global variable isn't just simply global to that game session, but it's global forever. And it's global in the sense that it is simultaneously the same instance of that variable from every session everywhere. We haven't exposed all of this functionality yet, but that's the future we're working towards. So for example, if you want multiple game sessions to have some kind of state that's being coordinated between the sessions, maybe a contest that's being played out across sessions, you'll be able to represent the state of that as just a global variable, rather than having to do network I/O, databases, and all that kind of stuff. We're not there yet, but that's the maximal future that we are working towards. So let me tell you about what we have exposed. First of all, we've exposed the ability to use globals in verse as the kind of globals you would have in a traditional language. The way we do that is using the weak map feature. Weak maps are just maps with one caveat. You can't enumerate over them. So if you have the key to the map, you can look up the value, but you can't ask for all the keys and values. Using that feature, we can expose just a legacy normal global variable like this. So if you want a regular global variable, would have been a global in any other language, the way you write it is, if it's the counter global variable, you write it as a weak map from session to whatever type you want, in this case, int. You can get session, and then when you get session and look it up in counter, you get the value of counter for your session. So that's like what a global variable would have been in any normal language. And you can use different types here. For example, it could be a class. But what we've done with this that's actually really exciting and useful for you all is that you can use this for per player persistence now. So we now also allow global variables that are weak maps keyed by player. So when you access this weak map, you're accessing state that will persist for that player forever for all sessions. So that's pretty cool. In this case, we've created a player states, and per player, we're saving a score and a checkpoint. But in order to support features like this, and in order to support the evolution of the metaverse, we need to have some rules for backwards compatibility. So going forward, you're going to see more and more of these backwards compatibility features. Right now, they affect persistence. So what that means is if you create one of these global variables that's a weak map from player to something, you won't be able to just arbitrarily change what that something is after you publish your game, because if you did, that would corrupt the saved state. You can certainly add new global variables keyed by player, but you can't remove properties, and there's limits on how you can add properties as well. In the future, when we allow for different folks' code to call into each other, this will also affect any kind of public API. So this doesn't happen yet, but in the future, watch out for this. If you publish something that's a public function in your module, then you will be required to have that function obey the signature that it was originally published with, so that anybody else who's relying on that function won't suddenly have their code break because you published an update. If you make stuff private, then it won't affect that. This brings me right into language versioning. This is a tough topic. Verse is a new language, and we're still fixing bugs in it. What that means is, in some cases, even a bug fix on our end, an attempt by us to fix an actual issue, potentially even an issue that might be causing crashes, we might end up, by virtue of fixing it, causing existing code to not work in the fixed version of our compiler. In order to mitigate that, what we've started doing is that language changes are versioned behind the scenes. So if you publish code with some version of UEFN, and then a later version of UEFN includes a bug fix that would have broken code that relied on the broken functionality, so long as you don't republish that project, that live project will continue to be compiled behind the scenes with our compiler switched into a mode where it's obeying the old rules before the bug fix. It's only if you go to republish your project that you will get the bug-fixed compiler that will potentially reject your code or give you the different behavior. Now, caveat here is that since in verse the assets are treated like verse, that means that if you publish an update that has no changes to your code but does include any other changes, then that means that the verse code is going to now be compiled under the new rules. So any kind of republishing of your project is going to encounter this. Obviously, as we evolve and make the language more stable, we hope that we just won't have to do this ever. But if we do have to do it, we're going to do it in a way that's mindful of the fact that we don't want to break your existing experiences, even if they're relying on functionality that wasn't supposed to be there, that was broken. I said that already. Additionally, we're adding an experimental attribute. When you go to the scene graph talk, for instance, one of the things about the scene graph is it's originally going to be released as experimental. The API that's marked experimental can be used in UEFN for playing around, but you won't be able to publish so long as that API you're relying on has the experimental attribute. So then that will give us an opportunity to have some time for feedback where we aren't locked into supporting whatever behavior is still experimental. And then when we drop the experimental attribute, then you'll be able to publish. Conversely, we've also added the deprecated attribute. The deprecated attribute right now is just informational, but the goal of it is that when we mark something deprecated, that means that the function is still available behind the scenes for already published projects. So us marking something deprecated isn't going to break live experiences. But if you try to go and publish an update to a project that uses deprecated API, in the future, that will mean that you'll have to switch away from using that deprecated API. But if you don't republish, your experience will keep working. We're going to make sure that even deprecated APIs keep working for projects that are abandoned for whatever reason or just simply not republished because y'all like them the way they are. Now, this is a really cool feature. This feature is not a language feature as much as it's a developer experience feature. We are soon going to release the ability for creators to look at runtime error telemetry for their published projects. So this is really cool. You'll be able to go to a URL that'll be part of our content service. You'll find out the URL when this is all ready to go. And you'll see top runtime errors and stack traces. So you'll no longer have to be in a situation where one of your friends is playing the game, they say something bad happens, and then you don't know what happened. You'll at least know if it was a runtime error, you'll know what it was. So that's really exciting. All right, now I want to tell you about my favorite feature. Since the end of the year, we've switched UEFN to using an incremental garbage collector. One of the challenges of using garbage collection is that it might hitch. It's not unusual for a garbage collector to need more than the amount of time you would have normally taken for a frame to stop everything, perform reachability analysis, and then free the objects. It's already been the case for years that Unreal Engine does the sweeping part of the garbage collector incrementally, but the reachability analysis had to be one stop-the-world hitch. But since the end of the year, we fixed that. And in UEFN, the garbage collector is incremental with an upper per frame limit of 2 milliseconds. So if you had a garbage collection that would have required, 30 milliseconds in order to perform reachability analysis, now what that'll mean is that it'll happen across 15 ticks, with each tick doing 2 milliseconds of work. And what's really great about this is that it's coming to UE 5.4, so anybody who's a UE developer will be able to turn this on in their experience. And the way that you would do that if you're a UE developer is you would set these console variables. If you're a UEFN developer, you don't have to do anything. You just get this by default. So let me just review a little bit about why hasn't this always been the case. It hasn't always been the case because it's actually a hard problem. It took a lot of work to fix this. So when the garbage collector is performing its reachability analysis across multiple ticks, that means that it's performing a graph search of the heap concurrently to the program changing that heap. The program might allocate additional objects. It might change references between objects. The way that we handle that is that new objects are allocated already marked reachable, which means that any objects newly allocated during that incremental reachability analysis phase just skip that phase. The phase just assumes that they're live. It'll be the next reachability analysis that will potentially delete them. And every store to a heap a field in the heap that points to another object is instrumented so that it marks the newly pointed at object the moment that you do the store. Behind the scenes in Unreal Engine, the way that works is the t-object pointer wrapper that we've added to all pointers to UObjects that are in the heap. So that's a refactoring that we've done in Unreal Engine and Fortnite. You don't have to use t-object pointer if you're a UE developer on the stack. So if you have local variables, your local C++ UObject pointers can just be traditional pointers. The garbage collector doesn't need to know about what you do about those during the reachability analysis. So if you want to use C++ references or pointers on the stack in local variables, totally fine. You only have to use them for pointers between UObjects. And the overhead of this is actually shockingly small. On a lot of workloads, the overhead of the t-object pointer barrier is 0. It's just not measurable. In extreme cases where we've been able to measure it, it's somewhere around 0.5%. Reason why is that the fast path of this instrumentation is just a load of a global variable and a branch on that global variable, and that's it. And it's uncommon that we end up taking the slow path where work actually happens, hence the very low overhead. Next, I want to tell you more about transactional memory. Transactional memory is a major feature of Verse. It's kind of fundamental to how Verse works, and it's fundamental to how we'll be able to do some of these exciting things like having a global variable that's shared between sessions. So let me go over 3 parts of this. One is AutoRTFM, which is a technology that we've started to deploy. Then I'll tell you about the plan for pervasive transactions and for global state. AutoRTFM stands for Automatic Rollback Transactions for Failure Memory. We just had a blog post that we published about it. Basically, what this gives us is Verse's transactional memory semantics in the engine C++ code. It's a new version of Clang that we developed, so it compiles the engine C++ code in such a way that when that code is called from Verse, that C++ code gets Verse's transactional memory semantics. What that means is that if you call into native code from Verse, of course, if you're a Verse programmer, you don't know what the native code is or isn't. If you happen to call into native code, that native code will, like Verse, have this behavior that if you abort the transaction, for example, by failing in a failure context or getting a runtime error, whatever stuff that C++ code would have done will be undone. And what this is going to take us towards in the future is the ability to run Verse gameplay code in parallel using transactional memory, even though the heavy lift of a lot of that code is the stuff that C++ code does when Verse calls into C++. The way that this will ultimately surface to the user is you won't have to write transacts everywhere. Right now, if you have a function that participates in transactions, which right now the way that that's exposed is if it has the decides effect, you also have to slap the transacts effect on there. And that's a way of revoking the no rollback effect, which is secretly placed on a lot of native functions. Because prior to AutoRTFM, a lot of native code could just simply not participate in transactions. So it'll in sometime this year, it'll mean that you'll be able to simplify your Verse code by removing the transacts everywhere. It'll also mean that you'll be able to call more functions from if statements and for loops. It'll just lead to simpler code. It'll also mean better runtime error recovery. What I mean by this is if you get a runtime error, right now, whatever the game was doing is kind of aborted there but not undone, which means that the state of your game after a runtime error is who knows what. But with AutoRTFM being applied pervasively and all Verse code running in a transaction, what that'll mean is if your code experiences a runtime error, then at least after that runtime error, whatever happened up to that runtime error is undone and you're back to a clean state. You won't be able to catch runtime errors yourself, but at least the state of the system will be in a known good state after an error. But also, having transactions pervasively will allow Verse code to participate in distributed transactions with a database. That's how we will get to this point where a verse global variable will be like a database. So you'll be able to read and write to it. And because verse code is always running in a transaction, whatever you do to that variable will be as if you were accessing an ACID database from within that ACID database's transaction. And if that database wants to do speculation, wants us to run some code speculatively, then roll us back and run us again, because that's how databases work, verse and even the engine will be able to participate in that thanks to AutoRTFM. So this is sort of the build up to that moment when we give you global variables that are truly global. Now I want to tell you a little bit about where we're going with MaxVerse. So far when we talk about MaxVerse, it's like a thing we know about internally, but there's not a lot available externally about it. So we're racing to create a reference implementation. It's not written in C++, it's not meant for the engine. It's actually written in Haskell. And we're going to release it as an open source thing, as well as a thing you can run in your web browser. So this will show you where the verse programming language is headed. And the promise is that the verse in UEFN is always going to be a strict subset of that and grow until it becomes that, which will allow us to perform validation as we go. So the reference implementation will be the standard that we compare against. All right, now I want to tell you about the new verse VM, which we're working on. Right now, verse executes on top of the old Blueprint VM interpreter in Unreal Engine, which works fine. The Blueprint VM interpreter is a solid, capable interpreter, but it's not optimized for verse. So we're building a verse virtual machine to give you more verse functionality and much better performance. So let me tell you about how the verse VM works, or some of the cool things about it. The verse VM is going to have super fast garbage collection, a totally new execution engine optimized for verse, and excellent integration with the engine along with those features. So the verse garbage collector is going to be concurrent in addition to incremental. What that means is if you hit a point where garbage collection has to run, the garbage collection work due to verse objects is going to happen on another thread concurrently to gameplay execution. It's not even going to add time at the end of the tick. And it interoperates seamlessly with the Unreal Engine incremental garbage collector. So the garbage collection reachability work that has to happen for native U objects will happen at the end of tick with that 2 millisecond or whatever time limit. But even outside of that 2 milliseconds where the Unreal Engine garbage collector is doing its work, the verse garbage collector will be doing its work concurrently on its own threads. So that'll enable really fast garbage collection even if your heap gets big or you're allocating a lot of objects without any kind of hitches, not even the 2 milliseconds at end of tick. The verse execution engine has some really cool features, including the fact that objects are super duper tiny. So in Unreal Engine, an object is hundreds of bytes minimum just because of all of the functionality that native objects in Unreal Engine have. But pure verse objects, so if you allocate an instance of a verse class that's non-native, or if you allocate a verse map or verse array or verse string, those are going to be all allocated using the new verse object model tied to the new verse garbage collector. And in that model, each object only gets an 8-byte header, and the minimum size for objects is 16 bytes. So if you have a class that has one field that'll fit in 8 bytes, that'll be a 16-byte object with that 8-byte header and then 8 bytes of payload. And there's no limit on object size, but the idea is that because the underlying baseline overhead per object is so tiny, you'll get better cache locality, and it'll take longer before you actually hit some kind of heap limit. So the hope here is that this will allow you to build much more sophisticated experiences because there will be less memory overhead per object introduced by the underlying engine. So that's a huge part of why we think the verse VM is going to be an enormous performance improvement for y'all. Additionally, the new verse VM has a bytecode format and bytecode interpreter specifically optimized for MaxVerse. So it's a lenient bytecode where the bytecodes are allowed to execute somewhat out of order, Despite that, it's super fast. In fact, the prototype that we have is already faster than the Betaverse implementation, and we're hoping for something like a 10x performance improvement when we ship it. And finally, we're doing all of this inside of Unreal. This isn't some new project on the side. It's tightly integrated into the Unreal Engine, so it'll have fast native calls from Verse into C++ code. And internally, we will allow ourselves fast interoperability between Verse and Blueprints. We don't have a plan for what that means for UEFN developers, but for someone who is an Unreal Engine licensee, that'll mean that you can have a mix of Blueprints, Verse, C++, and it can all call into each other. Additionally, what we're working towards is that in the Verse VM, the interaction between Verse and native code will be just like how it was with Blueprints, namely using the Unreal header tool. So if you want to expose C++ code to Verse as an Unreal developer, you just mark it up using the same uProperty Unreal header tool markup that you would use if you're exposing it to Blueprints, and that'll make it callable from Verse. All right, and with that, I'm going to hand it over to Tim with the framework update.
Thank you, Phil. So today we have quite a number of devices that we've exposed to Verse. They have various Verse APIs, various ways you can connect these devices together. And so right now, the short term is to give more device APIs as well as more interesting ways to kind of connect them together. And so it's really easy to take what UEFN has today and then to take Verse and kind of really empower it to take the experiences to a much higher level. Examples on the right-hand side I show here, various ways to track subscriptions, to display different game events or track stats, ways to spawn things dynamically in the scene, or ways to do things just like play VFX and things in ways that are much more easy to drive from code than from a lot of the existing mechanisms that require much of data hookups. The future we're heading for, though, is eventually we want to make it so that UEFN devices are not required to write Verse code because we're going to expose the underlying fundamentals that they're built with. There's a long journey to get there, mainly because there's a lot of existing legacy UE and Fortnite code that we kind of have to rewrite to expose in the way that Verse would like us to do that. But that's our long-term goal. We also want to give the ability for Verse developers to write Fortnite creative devices and to publish them so that people who don't write Verse code and just purely want to write their games using Fortnite creative on the console can use the tools that Verse developers create internally. So we don't have a timeline on this yet, but this is kind of where we're headed. So I want to dive a little bit deeper into persistence and kind of show how this is exposed in gameplay code. So here we have a game we made internally, and you can kind of see a bunch of code here. And I'm going to kind of break this down and to show you kind of the various persistence points. So initially you see we've added a persistable flag to an enum, a class, and then where those are kind of combined together in this persistence player data. And so the important part is that it requires this additional attribute persistable, which the compiler then verifies the types that you're putting this on are compatible with persistence. Some more details in the online docs I've linked to the bottom there. So once you have these types, then you can store them inside of this weak map that Phil referred to, which is really then defining this global variable, essentially, for players in this case. We plan to extend types on that in the future. And then to read basically from this online storage, we're ultimately writing and reading to this, essentially just a data type in Verse. Behind the scenes, though, there's a lot of work that actually goes on. But to the Verse code, you're really attributing your code, reading and writing to this weak map we declared. So some of the internals, I just want to share this, is our implementation may change, but it's sometimes useful to understand what's going on behind the scenes. So during matchmaking, we actually go and read from online storage everything that your particular project is declared as being stored in this weak map. And if the read fails, basically matchmaking fails. But if it succeeds, the player comes in and all their data is loaded before your Verse code ever gets a chance to look at it. And then during the simulation, that player data is persisted periodically to our backend storage. And then when a player leaves, we essentially release the player data lock that we held while the dedicated server was accessing that player storage. The one caveat here, which you may experience depending on stability of the game, if the server crashes, the client freezes, or somehow the connection freezes, in a way that the servers can't detect what's going on, you may be prevented from rejoining a game while that lock times out, which right now is set about 60 seconds in the worst case. So just a hiccup that does occur, but ideally not something that impacts the experience too badly. So one of the examples we have here in our internal game is we made just kind of a player elimination leaderboard. But there's lots of ways you could store various stats for that session, including personal save games, and things even deeper when you get into player quests that you want to store across multiple sessions of the game. And there's lots of other variations on this as well. And eventually we plan on exposing much deeper and richer types of interaction. So Phil referred to asset manifest and the fact that we want to try to make everything exposed to verse. So in this case, we look at the content in your asset browser, and we generate verse class references, essentially in this case, that you can then refer to directly in your verse code. So here we have some meshes and materials. And then from verse code, when I want to set a mesh or material on a prop, I can just refer to that path. So something that's coming soon is now we want to be able to expose additional parameters. So in UE, we have the ability to say here are parameters we want materials to have, and then be able to set those from code. So soon verse will have the same ability to take parameters and to set those on materials and other types of assets. So there's the simple version here where you basically define the variable, and verse exposes it as a simple property. We also want to have composite versions of this, where in this case I have some weather data that I've exposed. That has like temperature, rain, and wind speed, which then can all be passed into the material, and in this case also shared across multiple different materials. And then of course we want to be able to respond to gameplay. So if my player had armor on and they walked under a tree, I could set the local weather data for being under the shelter of that tree, which would be different from the rest of the environment. So it allows you to kind of dynamically change the scene itself as your gameplay determines necessary. Our goal, though, is to take this kind of pattern and apply it not just to materials, but also to UI, animation, sound, and VFX, and provide a very consistent way for the verse language to access different assets in the engine. Lots of work here. We don't have timelines on when all these assets will come in, but we're actively working on it. And one of the things we're also doing is trying to expose a lot of the powers under the hood that make the scene composable at a much deeper, richer layer. So the scene graph talk later today, we'll get into details there. The key part here is we also want to expose much richer content workflows. Namely, we call them prefabs, and ways you can interact with those dynamically in the editor as well as at runtime. One of the areas we've spent a lot of time internally in Verse is on AI. And so recently we released the ability to have custom behaviors and to create path navigation. And the code here we have the player we're telling to run initially to a spot, to play a particular animation, and then to walk back. But it gets much more complicated than this depending on what your game logic would like to have happen. We've also exposed a few features, like in this case, being able to block out areas of the world, like nav mesh navigation. Now I can place an object in the world and say I don't want the AI to navigate here. And this part actually is going to come in the scene graph later. Putting all those together then, you can have AI, you have custom interactions that you define with objects in the world. In this case, I have a tower. And I can also tell the AI to target that and have other things that occur as a result of the AI interacting with both the players and the environment. One example of a custom AI logic we wrote was creating a siege menu. We had two teams kind of standing off against each other and kind of had a stalemate. And we wanted them to be able to interact with the AI, in this case, where the AI would be able to support the player and heal the player as they kind of went in to fight the opposing team. And so the simple logic here is we're just checking for, what are my team members' current health, and if they're less than full health, see if they're determining if they're close to the AI here within the health aura effect range, and then heal them, and then play some VFX to kind of indicate to the player that they're being healed by their AI. So here's a quick video of that in action. In this case, I'm going to take out the shield generator here, and you see the guard there is now attacking me. And as my health drops, eventually I'll leave that area, come back out, and let the AI, you can see there, kind of begin to heal me. And then when I heal back up, I'll go back in and begin to attack again. And so there's this nice interaction where you're actually playing with the gameplay with the abilities you're adding to the AI itself for your game. lot of the AI right now is exposed through an NPC spawner device that came out earlier, I think it was end of last year, early this year. But it supports a lot of different types of NPCs. And so a lot of this, you'll notice in there, the second guard behavior, you'll see there's a verse behavior. So there's a default behavior that Fortnite gives them, but if you want to write your own custom behavior, then you'd select verse behavior and write your own custom verse script here. And down at the bottom, you also see a cosmetics section. So you can kind of put in, there's a whole bunch of variety of cosmetics we've exposed for you to kind of customize your AI. And down at the bottom here, I have some links to docs on NPC spawner, as well as metahumans can be used here as well. And so the nice thing about this is all the talks you've seen on metahumans here at GDC are allowed to do here on the NPC spawned AI as well. And we also have different AI in Fortnite, like wildlife. And there's more we're working on internally that will eventually arrive here as well. But a lot of the AI behavior, if you're interested, I would encourage you to go check out the Stronghold template. This kind of walks through basic AI behavior. So in this case, the Stronghold template has like some pathing defined, guards there, as well as interactions when the player comes within a certain range, how they respond and attack to the player. And there's all sorts of custom logic you could write on how you want your AI to interact with players. So here we see the player then beginning to assault the base that our AI are defending. And there's also perception that the AI has that will expose a little bit more powers in the future, particularly using the scene graph and ways to control that. But here you have the AI begin to engage the player. And there's ways you can control that kind of perception as well from verse and interact with it directly. So in the future, particularly with the scene graph, we're going to give you the ability to customize these in greater detail. And our goal, though, is to give you all the same control over the Fortnite AI that we have internally, and then eventually to give you the ability to write custom AI logic, including some of the more powerful AI tools dealing like with state machines and behavior trees. But that's kind of long-term roadmap where we'd like to head, and there's a lot of work kind of internally we have to iterate to get there. One of the pieces that we spent a lot of time internally on in part of the sandbox we created with Lego Fortnite was physics. And so when the scene graph releases, we'll have the ability for you to deal with scene queries, particularly overlap. And then shortly thereafter, we'll have collision responses you'll be able to write yourself, and then have deeper physics integration over the course of the coming year or two. And so I'd encourage you to go look at the Physics in Lego Fortnite talk, replay, if you haven't seen that already. It kind of gives some of the richness that we plan on exposing here eventually. When you put all these pieces together, you kind of have a lot of creative possibilities from all the different games we have in Fortnite. We're trying to expose all these to creators, so you have kind of a large sandbox. In this case, we have music, plus minifigs. There's many possibilities you can imagine, depending on what kind of IP or games you would like to use. Here's an example we built for the village that plays with camera and different ways you can interact with NPCs. So I encourage you to look at all the different examples we have out there and ways that you can kind of use these tools in your games. And here's a list of some of the different talks, particularly that were tie into the control you can have with verse with these different IPs. Some of them dealing with how I can control the styles dynamically via code. Other times you can use the cool things we've done with MetaHuman to control kind of the animation there. And so I highly encourage you to go check out these various ways in which you can expose your games to verse and control them much more richly than you can without using verse. But our goal really is to take all the powers we have in UE and to give those to the UEFN developers and to allow verse and the powers we have with being able to profile, look at all the various engine APIs, have the AAA level of diagnostics to see what's really going on behind the scenes, and eventually even make verse much more performant than Blueprint. And so our goal is really to make all of this ecosystem and verse itself be kind of this core of AAA gameplay. And a big shout out to thanks for everyone who's helped build this over the last year or so. And again, lots of people have been actively working on this behind the scenes. So I'd like to give them a shout of thanks for everything they've done.